Alright, so the next thing that we can do with the fact that we know the derivative of this function now, which is uh, 4x, 4x plus 4, well, we can do some pretty interesting things with it, namely what I'm about to do. So, first, let me just draw a quick graphic of my function, which is 2x squared plus 4x plus 6. Oh, okay. Okay, let me just draw that, and then another line over here, like this. Okay, that should be fine. Okay, so this function by memory, and I know what it looks like, don't ask why. It looks like this. I just know it looks like this because I've worked with this function for a while, so it looks like this. Basically, say that we want to find the vertex of this parabola. So this over here, HK, right? Since we have the, honestly, I'm not so sure what you call it in English, but in French you would call it the forme générale, which is, I guess, the general form of your function, which is just like you know, ax squared plus bx plus c. You're probably familiar with that. If you're not, yeah, I don't know, French or something. But if you're like American or something, but basically, you can find the vertex of this function by, and since it's like in the general form, you can find it by using h is equal to minus b over 2a, and k is equal to 4ac minus b squared over 4a. So this is like the algebra method of finding the vertex of the function. Algebra. I mean, we're still going to be using algebra, but in the next thing that I'm about to say, but anyways. So another way to do this is actually, and I could even find the vertex of the function quickly. So h would be minus b, which is minus 4, divided by 2 times a, which is 2 times 2, which is 4. So this would be minus 4 over 4, which is minus 1. And k would be 4 times a times c, which is 4 times 2 times 6, which is 48, which is, 8 times 6, 48. B squared is 16, so minus 16, over 4 times a, which is 8. This is 32 over 8, which is 4. So that means that the vertex of the function is minus 1, 4. Now, here's the second way to find it, by using calculus. This is the calculus method. Alright, so basically, usually when you use the derivative function, it's to basically like I don't know, you want to know the tangent, you want to know the slope of the tangent line at any specific x value. Like for example, I don't know, at x is equal to 2, you want to know what's the value of the slope of this tangent line over here, right? Well, oh my god, that's a really bad tangent line, but whatever. Oh my god, it's like it would look something more like this, probably. Like, not even, hold on, it would look something like this, I think. Oh my god. Anyways, it really doesn't matter. It's just gonna be a tangent line like this. It touches the curve at like one point over here. Okay, anyways, so usually what you would do is you would be asked to find the slope of the tangent line at one specific x value, for example 2. So then you would replace 2 in your derivative function, so it would give you like 4 times 2, which is 8, plus 4, which is 12. So the slope of this would be 12, right? Now, what we're going to be doing is, well, if we were looking at x is equal to 2. Now, what we're going to be doing instead is basically the inverse operation of that. Well, yeah. What we're going to be doing, instead of trying to find the slope at a specific x value, is I'm going to be trying to find a specific x value of a slope that I want. What I mean by that is, well, the following. The slope over here of the tangent line would be something like this, I guess. Oh my god, I'm really bad at drawing tangent lines. Something like this, probably. Over here, it would be something like this, I guess. Oh my god. Over here, like this. Over here, it would be something like this, I guess. And the more closer and closer you get to the vertex, the more, well, I mean, the less steep it gets, right? But if you get exactly to the vertex itself, what's going to be the slope of your tangent line? It's going to be 0, because the more closer and closer you get, the more the less steeper it gets. But when you get to your vertex itself, the slope of your function is actually 0. It's actually 0. It's gonna be like this. Oops. Okay, well that's 0. All right. So because the closer and closer you get to, because the further and further away you get from your vertex, the more steeper you're getting. I mean, over here you're steep in the negative direction. Well, you're getting more and more negatively steep, and over here you're getting more and more positively steep. Like for example, at this point over here, I will be steep like this. Over here, I will be steep like this. Oh my god, I'm so bad at this. Anyways, the more and more further away you get from your vertex, the more steep your function gets in a parabola. But at the vertex itself, it's 0, which means that what I can do is I can replace in my derivative function, which is f prime of x is equal to 4x plus 4. I can try to find the x value where f prime of x is equal to 0. So it's like I'm trying to find the x value where my slope is equal to 0, and I can just solve for x over here, and then you'll see that it actually corresponds to the x value of the vertex itself, which you'll see now. This is minus 4 is equal to 4x, so x is equal to minus 4 over 4, which is just minus 1, which is the x coordinate of the vertex. So, and just to find the, like let's say you were only using the calculus method to find the vertex, next what you would do is you would just insert it into your function, your original function. So that would be 2 times minus 1 squared plus 4 minus 1 plus 6. Remember, I'm using the original function now to find like the k value by inserting minus 1, this x value that I found of the vertex. Now you would just do this, so it would be minus 1 squared is 1, so 2 times 1 is 2, 4 times minus 1 is minus 4, plus 6, that's 4. So you found your vertex, the coordinates of your vertex, minus 1, 4. So basically that's how you would find the vertex of a parabola if you used the calculus method. You would find the derivative of your function. I should actually write this down. Find derivative of function. I'm going to call it FCT. Second, find x where f prime of x is equal to 0, and then you would find k. Well, actually, by finding x where f prime of x is equal to 0, that's the same thing as finding h, and then you will be able to find k by evaluating f of h, and that's it. That's the calculus method of finding the vertex coordinates of a parabola, and that's it.